Good day. Today we're going to discuss exponential equation. Now, to start the exponential equation, we have to define the exponential equation. When we say exponential equation, an exponential equation is one in which a variable occurs in the exponent. An exponential equation in which each side can be expressed in terms of the same base can be solved using the property if c raised to x equals c raised to y, then x equals y, for c not equal to -1, 0, and 1. So the exponent, okay, would be equal if the bases are equal. But we have to take note that our base should not be equal to -1, 0, or 1. Now, what will happen if we have -1 exponent? Now, in this case, for example, if the base is -1, and then let's say our x is equal to 3. Now, remember that our and then on the right side, if the exponent is equal to if the exponent is equal to 7 on the right side, they both got the same answer. However, the exponent are not equal. Same with 0 and same with 1. Therefore, C, the base must be not equal to -1, 0, or 1. If the bases are the same, then the exponent must be equal. Okay, now, if you can express both sides of the equation as powers of the same base, you can set the exponent equal to solve for x. Now, we have 2 raised to x is equal to 2 raised to 4, therefore, x is equal to 4. And then, if 5 raised to 2x is equal to 5 raised to 6, then we could say that 2x is equal to 6, which eventually, if we divide both sides by 2, then x is equal to 3. As we can see here in this illustration, if they have the same base, okay, for example, in this case, since they have both bases, which is 2, then their exponent are equal. Same here. The base is equal, the bases on the base in the left side and the base on the right side are equal, then the exponent also are equal. So we have to take note on that. Okay, now what are the steps in solving exponential equation with the same base? So for our step 1, okay, determine if the numbers can be written using the same base. If so, go to step 2. If not, stop and use the steps in solving an exponential equation with different base. For this lesson, we are not going to discuss yet the solving exponential equation with different bases. The examples that I am going to discuss are all examples which the bases can be expressed as equal. Okay. Step 2, rewrite the problem using the same base. Then step 3, use the properties of exponents to simplify the problem. And then step 4, once the bases are the same, write an equation involving the exponents by setting exponents equal to each other. And then the last step, finish solving the problem by isolating the variable. Now, okay, solve, for example number 1. Okay, solve 16 raised to 3x minus 5 equals 128 raised to 2x minus 4. Remember our step 1? Step 1, we have to determine if the numbers can be written in the same base. So if we go back to our main equation, so we have 16 raised to 3x minus 5 equals 128 raised to 2x minus 4. Now the bases are 16 and 128. Can we express 16 and 128 in such way that they have the same base? Yes, of course. Remember that 16 is equal to 2 raised to 4 and 128 is equal to 2 raised to 7. So in other words, we can use 2 raised to 4 to replace our 16 and 2 raised to 7 to replace our 128. So we have this case. So 2 raised to 4, okay, and then 2 raised to 7. So the 16 is being replaced by 2 raised to 4, and the 128 is being replaced by 2 raised to 7. So now we already rewritten the equation using the same base. Now, we can now use the properties of exponent to simplify the problem. Remember that the 2 raised to 4, and then we have another exponent 3x minus 5. In the right side, okay, the 2 raised to 7, and we have another exponent which is 2x minus 4. In this case, we are just going to multiply the exponents. So 2 raised to 4, the 4 will be multiplied to 3x minus 5. So 3 times 4, 3x times 4, we have 12x. And then we have 4 times negative 5, that's negative 20. Here, we have 7 times 2x, we have 14x. And then 7 times negative 4, we have negative 28. Okay, so we have that one. So as we can see here, no other parentheses. There's no more parentheses rather. So you have 2 raised to 12x minus 20 equals 2 raised to 14x minus 28. Now, since the bases are equal, the exponent must be equal to each other. So we have to write only the exponent. So 12x minus 20 equals 14x minus 28. Okay, so we have to isolate the variable. To isolate the variable, since we have 14x on the right side and on the left side we have negative 20, then we have to subtract both sides by negative 14x plus we have to subtract both sides by 14x and add 20 to both sides. So we have this one. So 12x minus 20, and then the 14x, we have to subtract 14x to both sides, and then we have to add 20 to both sides. So 20 to both sides. And then we have to combine the like terms. So here, 12x minus 14x, we have negative 2x. Negative 20 plus 20 equals 0. Here, 14x minus 14x, that's equal to 0. And then we have negative 28 plus 20, we have negative 8. So, we have negative 2x equals negative 8. Now, since we are going to get the value of x, then we have to divide both sides by negative 2. So negative 2 divided by negative 2, that's equal to 1. So the right side remains x, and then negative 8 divided by negative 2, then it's equal to 4. So the value of our x here is equal to 4. Therefore, the solution of 16 raised to 3x minus 5 equals 128 raised to 2x minus 4. The solution is 4. Okay, let's have another example. Solve 9 raised to 2x minus 3 equals 27 raised to x plus 4. Now remember, our first step is we have to determine if the numbers can be written in the same base. So our original equation, we have 9 raised to 2x minus 3 equals 27 raised to x plus 4. The bases are 9 and 27. Now, can we write 9 and 27 in such a way that they will have the same base? The answer is yes. They can be rewritten in such a way that they have the same base. Remember that 9 is equal to 3 squared and 27 is equal to 3 cubed. So in this case, we have to rewrite the equation using the same base. So the 9 is being replaced by 3 squared and the 27 is being replaced by 3 raised to 3. Now, we can use now the properties of exponent to simplify the problem. Now, since we have exponent 2 and 2x minus 3, then we can multiply those exponent. Okay, same process on our right side. The exponent 3 is to be multiplied to x plus 4. So, 2 times 2x, that's equal to 4x. 2 times negative 3, that's equal to negative 6. In the right side, 3 times x equals 3x, and 3 times 4 equals 12. So, we will have 3 raised to 4x minus 6 equals 3 raised to 3x plus 12. Now, we can now have, since they have the same base, then we can now equate the exponents. So we have 4x minus 6 equals 3x plus 12. And we can now isolate the variable. Since on the right side we have negative 6 and uh, on the left side we have negative 6 and in the right side we have 3x, then we have to subtract both sides by negative 3x and then add again both sides by positive 6. So we have 4x minus 6 minus 3x, that's this one, minus 3x, plus 6, because we have here, equals 3x plus 12 minus 3x plus 6. So whatever we did in our left side should be done also in our right side. Now we can now uh, combine like terms. So 4x minus 3x equals x. Negative 6 plus 6 equals 0. Okay, here 3x minus 3x, that's equal to 0. And then 12 plus 6 equals 18. So we have x equals 18. Therefore, the solution or the number that we can replace x in our given equation to make it equal, okay, x must be equal to 18. So the solution of 9 raised to 2x minus 3 equals 27 raised to x plus 4 is 18. Okay, let's have another example. Solve 16 raised to 2x plus 4 equals 1. Okay, so determine if the numbers can be written in the same base. So remember our bases are, we have 16 and 1. Now, can we express both bases? Okay, can we express 16 and 1 that they will have the same base? Of course, we can. Remember that 1 equals 16 raised to 0. So any number that we are going to raise it by 0, the answer is 1. Okay, so since we have 1, then we can rewrite 1 as 16 raised to 0. So we can now write the equation in such a way that they will have the same base. Okay, so we have 16 raised to 2x plus 4 equals 16 raised to 0. In this case, we can now use the properties of exponents to simplify the problem. However, in our problem, they're already in the simplified form. Okay, so we should now proceed to the next step. Okay, so since the bases are equal, then we could have 2x plus 4 equals 0. Now, we have to isolate the variable. So since we have 4 on the left side, so we have to subtract both sides by 4. Okay, So 2x plus 4 minus 4 equals 0 minus 4. So what remains? We have 2x equals negative 4. Divide both sides by 2, then we have x equals negative 2. Therefore, the solution of 16 raised to 2x plus 4 equals 1 is negative 2. Let's have example number 4. Solve 5 raised to 3x over 25 raised to x plus 1 equals 1 over 125. First step, determine if the numbers can be written with the same base. Okay, so we have the original equation, and then the bases are, we have 125, we have 25, and then we have to rewrite the equation with the same base. Remember that 25 can be written as 25 5 squared. Okay, why are we are going to have 5? In the numerator, we have 5. So as much as possible, they will have the same base. Okay, so 25 can be written as 5 squared, and 125 can be written as 5 cubed. So we have 5 raised to 3x over 5 squared times x plus 1 is equal to 1 over 5 cubed. So in this case, we can use the properties of exponent to simplify the problem. Okay, so we have to multiply 2 to x plus 1. So you have 2 times x, that's 2x. 2 times 1 equals 2. Okay, now, since in this case, they are now already on the same base. So, on the properties of exponent, if the base are equal and then the operation is division, then we can subtract the exponents. So we have the 3x here minus the exponent 2x plus 2 is equal to 5. Remember that this is the 1 can be rewritten as 5 raised to 0. Okay. So the 1 here can be replaced by 5 raised to 0. Now, in this case, we have 5, then 0 minus 3 is equal to negative 3. Okay. Now, since the base are equal, then we can now equate the exponent. So we have 3 minus the quantity 2x plus 2 equals negative 3. Okay, so we can now isolate the variable. Okay, now we have to remove the parentheses since we have negative here. Then we have to distribute the negative to the numbers inside the parentheses. So you have negative times 2x, that's negative 2x, then negative times positive, that is equal to negative. So we have 3x minus 2x minus 2 equals negative 3. Now, since we have negative 2 in the left side, then we have to add both sides by 2. Okay, 2 alone because on the right side, we don't have x here. So only 2 will be added to both sides. So you have 3x minus 2x minus 2 plus 0, minus 2 plus 2 equals negative 3 plus 2. So 3x minus 2x equals x. Negative 2 plus 2 equals 0. Negative 3 plus 2 equals negative 1. In other words, x is equal to negative 1. Okay, let's have another example. Here, let's have 3 raised to x squared minus 5 minus 9 raised to x minus 1 equals 0. So determine if the numbers can be written with the same base. Okay, so we have 3 raised to x squared minus 5 minus 9 raised to x minus 1 equals 0. The bases, we have 9 and 3. So 9 can be written as 3 squared. Therefore, we can have 3 raised to x squared minus 5 minus 3 squared. Okay, and the 2 would be multiplied by x minus 1 equals 0. Okay, so use the property of exponent. So we have 3 raised to x squared minus 5 minus, okay, the 2 here will be multiplied to x minus 1. So you have 2x minus 2. So 2 times x, that's 2x. 2 times negative 1, that's negative 2. Is equal to 0. And then, we can add both sides by this one. So, we have, since this is minus 3 raised to 2x minus 2, then we have to add both sides by this equation. So, in other words, we have 3 raised to x squared minus 5 equals 3 raised to 2x minus 2. Since they have the same base, then we can equate the exponents. So you have x squared minus 5 equals 2x minus 2. Okay, and then isolate the variables. Okay, we have to add, okay, both sides by we have to subtract both sides by negative 2. We have to subtract both sides by 2 and then add by 2 again to make the right side 0 since we have x squared here. So subtract both sides by subtract both sides by 2 and then add by 2. So we have x squared minus x squared. By the way, here in this, we have to combine like terms. So we have to copy the x squared. Negative 5 plus 2, that's equal to negative 3. And then copy negative 2x. So here, 2x minus 2x, that's equal to 0. Negative 2 plus 2 equals 0. So we have x squared minus 2x minus 3 equals 0. Then, can we express the right side, the left side rather, in a factored form? Yes, we can. So, what is the number what are the two numbers that if we multiply them, the answer is negative 3. But if we add them, the answer is negative 2. So those numbers are negative 3, positive 1. Because negative 3 times 1, that's negative 3. Negative 3 plus 1 equals negative 2. Therefore, our factors, we have the quantity x minus 3 times the quantity x plus 1. Then, we have to set both factors equal to 0. So we have x minus 3 equals 0. So what would be the number that you have to subtract it by 3? The answer is 0. Then we have positive 3. In this case, what would be the number that if we will add by 1, the answer is 0? So the answer is negative 1. Therefore, we have two values of x. X can be 3 or negative 1. Okay, that's it for today.